Welcome back. Yes, I am still Bob Fuller, but as you can hear, I now have a new voice. It is AI generated, which makes it much quicker and easier to produce the tutorials in different languages. It will greatly assist me if this new development is acceptable, so let me know what you think. In this episode, we practice applying the rules described in the iTrain signal rules document. Our task is to reproduce the signaling system shown in the iTrain demo layout, but by only using single-roll signals, as shown in this modified layout. Creating any type of signal involves the same four-step procedure described in the document and shown in video 4. Place the signal object, define it, group it, and assign it. In fact, we use a similar procedure for creating any type of accessory. The important difference with signals is the need to place the signals on the switchboard, as per the signal rules, rather than replicating the positions of the real, physical signals on your layout. Because the signal location on the switchboard determines how iTrain interprets and assigns the role of the signal, and how it establishes the relationship between a warning or distant signal and its related main or home signal. Our reference template for where to place the signals will be Figure 1 in the rules document. It shows us that the home signal should always be located near the end of the block, in the direction of travel. If the block contains a warning signal that is related to the home signal within the same block, it must be located somewhere near the start of the block. If the block contains a warning signal that is related to the home signal located in the block ahead, it should be located somewhere after the home signal, but still within that block. And if the block contains a shunt signal, iTrain prefers that it is located somewhere just prior to the home signal. For this exercise, I have created a modified version of the layout, with all the signal icons and elements removed. In some blocks, new track sections have been included to allow room for the additional signals needed. Although German signals will be used in this tutorial, it is still relevant to all regions that use single-roll light signals, or that use mechanical semaphore signals. Simply substitute the signals used in this tutorial with your regional equivalent. It's a 20-minute tutorial, but broken into clearly defined short sections, which you can easily navigate to, using the timings shown in the video description, or using the YouTube chapters shown in the play bar. So, let's get started. Open the switchboard editor. We will begin in the shadow station area. It contains 3 blocks that are unidirectional, and so each only require a single home signal. Step 1 is placing the signal. Starting with block SSB1, as per Rule 1A, home signals are always placed near the end of the block, in the direction of travel. The German DBHV signals are different to other regional groups, in that they have 3 types of home signal: the block signal, the curve signal, and the in signal. Each with a different set of states for use in specific situations. The block signal is used where the route to the block ahead always has an unrestricted speed path. We covered speed paths in the previous episode. The curve signal is used where the route to the block ahead always has a restricted speed path. And the in signal is used where the route ahead can go to different blocks, and where both are restricted, an unrestricted path is available. For block SSB1, this means a curve signal is needed because of the branch-restricted setting of this turnout. Simply select the appropriate signal for your region from the menu on the right. If your regional signals are not shown, right-click and select the group. Then, rotate the object, using the R or T keys, to match the track direction where it will be located. German signals operate from the right-hand side of the track. Select the square where it is to be located, and press the space bar to place it. Because I first rotated the signal to match the track direction, and then placed it in a section of track, which is already grouped, the grouping to the block is conveniently retained, as indicated by the brown color of the track. Step 2 is defining the signal. Double-click to open its properties. Give it a unique name, an optional description. At this stage, we are only using virtual signals, with no connection to the physical signals on the layout. Meaning, we do not need to define an interface or address at this stage. Addresses will be explained in a later tutorial. We just need to set the initial state, which we can leave at the default, HP0. And we need to enable the required states. Then press OK to save it. Now importantly, check that the signal name is listed in the Accessories tab on the left, because that confirms the signal has been created. The grouping is already completed, so we can jump to step 4, assigning the signal. To do that, open the block properties. The signal is orientated for direction next, so open that tab. According to assignment rule 2b, we should expect the signal name to appear in the Home Signal field when the autofill button is pressed. And yes, there it is. iTrain has automatically assigned the signal for us, and is therefore aware of its location, its properties, and how to control it. And that is the process used for every signal created in this tutorial. So, to save time, I have named, defined, and placed all the signals that we will be using in this modified layout, but have not yet assigned them. As we work through each block, I will explain the signal placement and show the signal assignment process. Here, I have completed block SSB2 and SSB3. I used a curve signal, again, in B2, because the path to the block ahead always has a restricted speed. In B3, I used the block signal, because the path to the block ahead is always unrestricted. Both signals were correctly assigned upon pressing auto-fill. So, let's move to the next block. To make it easier to see the extent of the block, I will use the G group key to highlight it. In block SSBO, the original file only contained a combined home and warning signal that provided an advance indication of the home signal located in the block ahead. But I also want to add another warning signal at the start of the block that will indicate the state of the home signal located at the end of this same block. I used Rule 1A to locate the home signal and selected the block signal because the path to the block ahead is unrestricted. I used Rule 1C to determine the locations of the two warning signals. Placing the first warning signal at the start of the block means it will be related to the home signal located within the same block. And placing the second warning signal anywhere after the home signal but still within the same block means it will be related to the home signal in the block ahead. I defined and grouped each signal using the same process previously described and ensured they have unique names. I also enabled the appropriate states of the warning signals, VR0 and VR1, to match its related block signal, and VR0 and VR2 to match its related curve signal. The next step is assigning them. So, open the block properties and select the Direction Next tab. Again, Rule 2b tells us to expect the home signal to appear in the Home Signal field. Rule 2d1 says the warning signal that provides an advance indication of the home signal located within the same block should appear in the Warning Signal field in the Signals section. And Rule 2d2 says the warning signal that provides an advance indication of the home signal located in the block ahead should appear in the Warning Signal field in the block section. So, press the Auto-Fill button. And yes, the signals have been correctly assigned, and their names are listed in the browser. Press OK, and we can move to the next block. The signaling for block CSBI is quite interesting. Its home signal protects the entry into the central station where there are multiple different paths that the train can take. Each path is configured as branch restricted. So, for the German DB/HV signals, this requires a curve signal. The single warning signal needs to provide advance warning of the state of the home signal in the block ahead, depending on the route chosen. This means it needs to have a relationship with each of the home signals in all of the possible routes ahead. That sounds like a daunting task, but in iTrain, it is easy to accomplish. All we need to do is place the signals in the correct locations as per the signal rules, and then let iTrain do its magic. When the signals for each block are installed and the autofill button is pressed, iTrain automatically assigns the signals for us and establishes any necessary relationships with signals in the other blocks. It does not matter if the signals in the other blocks have not been drawn yet. As we create the signals for the other blocks and assign them, iTrain will automatically establish the relationships between the signals. So, I placed the two signals in block CSBI as per Rule 1A and 1C, and defined and grouped them as usual. For the warning signal, I have only enabled VR0 and VR1 because all its related signals ahead are all effectively the block type. The terminated blocks are seen as permanent red stop signals, regardless of whether signals are fitted or not. Rule 2B and 2D2 then tell me how the assignment should appear. And yes, the two signals have been assigned, as expected, with the warning signal assigned to the block section. Simple. A terminated block obviously must be a bidirectional block, so signals would be needed in both directions. But iTrain automatically treats a terminated block as a red stop signal at the terminated end, so there is no need to place a stop signal in that direction. For these two blocks, we just need a home signal on the exit and a shunt signal to allow shunting maneuvers between platforms. Rule 1A defines the home signal placement. So, a block signal for CSB1, because the only viable exit path to the next block is straight ahead. Remember to orientate the signal on the correct side of the track for the direction of travel. For CSB2, a curve signal is used because the exit path is always restricted. Rule 1D tells us that iTrain prefers a shunt signal to be placed prior to the home signal, so I placed the shunt signals here. After defining and grouping each signal, Rule 2B and 2C tell us where the signals should be assigned when I press the auto-fill button. But nothing has been assigned to the fields. The reason is because the signals are installed in direction previous, so we need to select that direction tab. And there it is, the shunt signal is showing as correctly assigned to the shunt signal field. Block CSB3 is bidirectional and contains a decoupler to allow runaround maneuvers to be performed. Train departures and shunt maneuvers are possible in either direction, so a home signal and shunt signal are required at both ends of the block. A block signal for direction next and a curve signal for direction previous. Rules 1A and 1D tell me where to place them. I've defined and grouped them, so I just need to assign them. And yes, they are correctly assigned for direction previous, and clicking on the Direction Next tab shows the other two signals. Block CSBT is unidirectional, and if you are using two-rail track, it functions as a so-called turn loop or reversing loop, where polarity switching of the track occurs. In that case, it is needed to allow trains to use this switchback path without causing an electrical short. In this layout design, a similar reverse polarity section would also be needed before the entry into or exit from the shadow station to switch the polarity back again. Polarity switching has no effect on signals, so, for signaling, we treat these type of blocks just like any other. The original layout contained a solitary in signal, but I will replace it with a block signal and also add a related warning signal. Its enabled states are VR0 and VR1. After pressing Auto-Fill, the signals are correctly assigned, with the warning signal in the signal section this time. Okay, moving on, I have installed the signaling for CSB4. It is like CSB3, except for the following. This block signal only needs the HP0 state enabled, because normal train routes into CSBT are not permitted in direction previous, it is a unidirectional block. However, a shunting route into CSBT is permitted, and hence the use of the shunt signal. In direction next, the correct signal to use here is the curve signal, not the in signal, as you might initially think. The in signal is normally used when there is a choice of restricted and unrestricted paths to the blocks ahead. That appears to be the case here, but block CSB04 changes that because it is designated a shunting block. In a shunting block, signaling is ignored by iTrain, hence why there are no signals in CSB04. So, from a signal perspective, iTrain ignores the straight unrestricted speed on the entry into the block, and, instead, looks ahead to the next block, where signaling is enabled, and here, the entry is branch restricted. And so, from CSB4, iTrain sees the paths to the blocks ahead, as both branch restricted, and hence why the curve signal should be used. A typical use of a shunt block is to allow a loco to wait in the block, out of the way, and allow another train to enter or exit platform 4 without affecting the signaling. Open the block properties and assign the signals, checking that each assignment is correct. Not forgetting to check the signals in the other direction also. The signals for CSBO operate in the same way as SSBO, so I used the same process shown earlier. This warning signal is related to this block signal within the same block, so I only enabled its VR0 and VR1 states. This warning signal is related to the in signal located in the block ahead, so I enabled its VR0, VR1, and VR2 states. Press Auto-Fill and check the assignments. Lastly, we have block CSBI, in which the signals need to protect the entry into the shadow station. There are 3 possible entry routes. A restricted path into track 1. A restricted path into track 2. Or a completely unrestricted path into track 3. So, here, the in signal is required, with its HP0, HP1, and HP2 states enabled. And hence why the relevant VR states were enabled in its related warning signal in the previous block. Press Auto-Fill and check the assignments. So, that completes the creation of the virtual signals in this layout. Press Apply, Save, and OK to exit. And, as always, whenever any changes are made in the switchboard, we should run the diagnostics to check if any errors have been created. All is good. We can perform a quick test of each virtual signal by manually changing their states. But to properly test the full signaling system, we need to run train routes through them. We can, of course, do that in offline mode, and I strongly recommend that you do so, to verify the virtual signal operation, before attempting to connect the real, physical signals. Then, if there are any problems, you know it is in the software setup, and not the physical hardware. But this video is already long enough, so I will show the testing in a later tutorial, when the real, physical signals have been installed, and addresses have been set up. So, that is all for this tutorial. Hopefully, it provided some interesting examples that emphasized the importance of placing the signals, as per the iTrain signal rules document, and not trying to replicate the exact positions of the real, physical signals, on your layout. Locating the signals correctly allows iTrain to automatically assign the signals for us. And that is the easiest, most efficient, effective and reliable way of creating signals. In the next episode, we will repeat the exercise, but this time only using multi-role signals, which have much simpler placement rules. So, until then, bye for now.